let us discuss first topic, what is electric dipole. Electric dipole consists of equal and opposite point charges separated by a small distance. We have two charges. The first charge is plus q, another charge is minus q. Plus q and minus q, both the charges are of same magnitude, that is q, and they are opposite, as one charge is positive charge, another charge is negative charge. They are separated by a distance 2a. At the middle of this line we have a point O. This point O is called center of the dipole. The distance of plus q charge from the point O is a, and the distance of minus q charge from the point O is again a. This O point divides the separation into two equal parts. For example, if you have plus 7 coulomb charge and another charge is minus 7 coulomb, you separate these point charges by a distance of 1 millimeter. 1 millimeter means 10 raised to power minus 3 meter. So this assembly forms an electric dipole. The total charge on the electric dipole can be calculated by knowing that charges can be added algebraically. So the one charge is minus q, another charge is plus q, so their sum will be equal to 0. Similarly, if one charge is plus 7, you add minus 7 coulomb into it, the net charge on the dipole is equal to 0. Next topic is about the dipole moment. Dipole moment is a measure of strength of the electric dipole. It is given as P. P is the representation. P is equal to Q into 2A. P is equal to Q into 2A. So, dipole moment has a magnitude which is equal to product of the magnitude of either charge. Means you can take either plus q charge or the minus q charge. One of the charges there and the distance between them. We have written P is equal to QA, where Q is the charge and this 2A is the distance between the two charges. Dipole moment is a vector quantity. It has direction from negative charge to the positive charge. Let us look at the SI units of dipole moment. As we write down, dipole moment is product of charge and the distance between them. We know that the SI unit for charge are coulomb and for the distance 2a the units are meter. So the dipole moment has units coulomb into meter. The dimensions of dipole moment can be calculated by starting from the equation of dipole moment, which is P is equal to Q into 2a. For A, the dimensions are length, and for Q, the charge, it is written as product of current into time, because we know that the current is rate of change of charge with respect to time. So current is measured in amperes, so we write A here and the time as a capital T. So it will be ATL, and there is no mass involved, so we write m raised to power 0. L, the power is 1 from here. The T, the power is 1 from here, and A with 1 power. So the dipole moment has this dimensions. Next, what is ideal dipole? It is one of the question asked during the board in previous years. We know that the dipole moment is given as P is equal to Q into 2A. If the Q charge gets very large, if the Q charge gets extremely large and the separation between the charges become very small, at that situation, when Q gets larger and larger and the separation 2A between the charges gets smaller and smaller, during that situation, our arrangement shifts into an ideal dipole. Ideal dipole has almost no size. Next, let us discuss what is dipole field. The dipole field is the space around the dipole in which electric effect of the dipole can be experienced. So we have this dipole minus q and plus q separated by a distance of 2a. Then the field around it, the field around this dipole in which you can experience the electric effect of this dipole is called dipole field. Then let us understand what is axial line and what is equatorial line. This is minus q charge and this is plus q charge. They are joined by a line that is two-way. The line joining the minus q charge and the plus q charge is called axis of the dipole. This line is called axis of the dipole at which you have placed the charges. If you extend this line and place any test charge, say plus 1 coulomb on this line, then this plus 1 coulomb charge lies on the axial line of the dipole. In simple words, we can say that the axial line is the line which is extended from the line which joins the charges minus q and plus q. Another line is the equatorial line. Equatorial line is a line which is perpendicular to the dipole axis. It makes an angle 90 degree to the dipole axis, and this line passes through center of the dipole. It has two conditions. First, it is perpendicular to dipole axis. This is first condition. Second condition, it passes through the center of the dipole. Any point which lies on this line, right, will be called as a point lying at the equatorial line of the dipole. One thing is very interesting to note here, that when you put a point on the equatorial line, then this point will have equal distance from both the charges. They will be placed at equal distance.